Hello, my name is Dr. Abrahamogwu. I hold degrees in engineering, physics, undergraduate, and a master's and a PhD in material science and engineering. I am completing a higher education teaching certificate at the Harvard Buck Center. You are all welcome to this class. Today, I will be introducing you to some of the basic concepts in physics, like weight, mass, and time, and how the physics definition of these topics differs from the everyday definition. In the interim, I would give you the opportunity to introduce yourself to me by standing up, or if you prefer to sit down, you give me your name and your prior educational background, and then we can commence the course. So if you also have some interest in physics, perhaps you might want to tell me what are the specific areas of physics that are of interest to you, because you are most likely going to find some relationship between that interest and these very basic things that we want to cover today. So essentially, people talk about what they weigh. Oh, I weigh, so many kilograms. And then some other people will talk about mass. And what is the mass of an object? And the issue is there is a difference between the weight and the mass. And it's very important to be able to differentiate the two. The weight that an object has is tied to the location of the object. So when objects are on a planet, such as our planet, planet Earth, because of the mass and size of that object, it has the potential to pull other objects towards it. So the bigger the planet, the heavier the weight of objects, the heavier the weight that objects will have on the planet. But weight itself is composed of two sides. There is something called a mass, and there is something called the acceleration due to gravity. It is the product of the mass and the acceleration due to gravity that actually determines the weight of an object. Now, if you remove an object from a massive object and you take it into space, where that other object, which is more massive than it, is no longer able to influence it, what you are left with is the mass. And that is why we talk about weightlessness in space. Because if there is no gravitational pull, the object will be left only as a massive object. It doesn't have a weight. Interestingly, our weights are generally constant unless we take some actions such as dieting or exercising to try to drop the weight. But our weight is not constant when we move from one planet to the other. So a human being who weighs 100 kilograms, for example, on our planet, if they go to the moon, they will weigh far less because the moon is smaller in size than the earth. So it has less gravitational pull on objects. So people who normally would not be able to scale, high fences, will be able to do so easily when they go to the moon because the gravitational pull on them and hence their weight will be less than what it is on Earth. And if people are able to go to other more massive planets, they will find out that they will weigh far more than they weigh on Earth. The way I'm going to be taking you through this course is, to give you the basics of the weight, the mass that I've already done, and time. Time is another concept that we all have a way of feeling that it's the same for every observer. But in physics, you will find out that time can be dilated, and that is a topic I'll come to in a later section of this course. So essentially, we are going to have 2 quizzes and 1 continuous assessment, which you will do from home on this course. And you will be expected to submit your take-home assignment on a fixed date. We might be able to give you an extension, but that will be subject to providing a satisfactory reason why you couldn't meet the deadline for teaching this course. Also, a part of the requirement for this course is that you will be punctual. You'll be able to start the class at 9 a.m. and you will remain in the class until we finish at 11 a.m. except when we take a 10 minutes break in between the lectures. And you will also have the opportunity to carry out some exercises in the class as we progress, some of which will be descriptive and some of which will be numerical. You would indicate an interest in carrying out these exercises by simply raising your hand, and then you'll get called to come to the front of the class and make the attempt at the question that is posed to the class. Please kindly feel free to stop me at any point during the class if you feel that the concept I'm introducing to you is a bit unclear to you, so that I can, come up with the best way to engage you. So we'll be using a mixture of learning tools on this course. I will be using PowerPoint notes, and then I will be showing you some videos and some animations will be carried out also on the computer. This is all meant to aid your understanding of the course, so that at the end of this course, you will not only have understood what is the mass of an object, what is the weight of the object, how long in time does it take for this object to travel a certain distance, and if it was an experiment that was carried out, for example, on the moon, would there be a time difference between the time difference on the Earth and the time difference on the moon? And this is how the building blocks of physics work. So we identify the laws of physics and then we try to apply them in various frames of reference. Thank you.